I will let you read the question. Well, it looks to me like I need my derivative function. Very much my last example to find critical numbers. Notice how this derivative function is always defined. Excuse me. So if I do generate any critical numbers, they're going to be obtained by identifying when this happens. So it looks to me like I have three critical numbers. Now, just because I have three critical numbers does not necessarily mean they yield local extrema. So if you don't mind me taking a break, I am actually going to build a sign graph. So I'm going to create a number line. I'll label it clearly as a derivative function's number line. I will plot my three critical numbers. Notice that these three real numbers subdivide real number line into four subintervals, and I'm going to check them. So here I go. If x is a billion, well, when I plug a billion in for x into my derivative function, which I factored as such, my apologies. Like I said, when I substitute a billion in for x, here, here, and here, I have the product of four positive real numbers, and the result's going to be positive. Now, I personally am the thing I always say I am. Too lazy. So if you don't mind me saying, since each and every one of these three real numbers is a zero of a linear excuse me, factor here, here, and here, then each one of these real numbers is going to act as a toggle switch. I will change signs. If you don't like my lazy approach, don't listen to me. Check each subinterval individually by choosing a value of x here, here, and here. Plug in for x to see if your first derivative function is positive or negative. Now, to finish up answering my question, to say the derivative function is negative here simply means the original function f is decreasing. Then it increases, decreases, increases. These are not values of x for which I have vertical asymptotes because the original function was defined everywhere as well as derivative function. That being the case, is at this value of x I attain a local min, as well as this one. Is at this value of x at which I attain a local max. Now, for me to state that officially, can I take the time to erase a little bit and officially state my answers? To answer the questions I've asked, I will formally say the following. So I attain a local min at these two values of x, but I have to confess, at these two values of x, the output's the same. Now, it looks to me like I erased the original function, but as I recall, I believe it was this. So to actually come up with the actual output, the actual local minimum, that would be the y value that's obtained by picking up these two real numbers, sticking for x here and here, and find out the output of the original function. But it looks to me, if I plug 1/2 or negative 1/2 in for x here and here, is that going to give me a 1/4 minus 1/2? Which is just negative 1/4. Now look carefully what I've just done. I've identified that there's only one local min, but it occurred at two different locations. That occurs at that value of x. And that maxima is my function evaluated at 0, which clearly is 0 itself.